ಏನಿಲ್ಲ ಅಲ್ಲಿ ಸೀಸನ್ ಮುಗಿಸಿದ್ದು ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ ಅಷ್ಟೇ.
Hello, am I audible? Am I audible?
ಆಯ್ತು ಸರ್. ಸೈಟ್ ಕಾಣಿಸ್ತಾ ಇದೆ. ಈಗ ಆಫ್ ಮಾಡಿ ನಾನು ಇದ್ರಲ್ಲಿ ಮಾತಾಡ್ತೀನಿ.
ಕರೆದ ಮೇಲೆ ನಮ್ ಬರ್ಲಿಲ್ಲ ತಪ್ಪಾಗಲ್ಲ.
Am I audible to everyone? Am I audible to everyone? Hello? Am I audible to everyone?
Nagaraj sir, audible?
ಹಾಂ ಸರ್, ಆಡಿಬಲ್. ನಂದು ಸರ್.
Sir, ಕೇಳಿಸ್ತಾ ಇದೆ.
ಓಕೆ.
Sir. So we'll start the session at exact 10 o'clock, sir.
Okay.
Thank you.
ಸ್ಟಾರ್ಟ್ ಆಗಿತ್ತಲ್ಲ ಸರ್ ಈಗ? ಓಕೆ ಅಲ್ಲ?
Okay.
ಲೈಟ್ ಚೇಂಜ್ ಆಗ್ತದೆ.
Yes, sir.
Nagaraj sir,
Hello, sir, ready, sir.
shall we start?
Sir, I'm ready.
Okay, sir.
Fine.
It's our pleasure to welcome Dr. Nagaraju C, Assistant Professor in the Department of Electronics and Communication Engineering at NIE Institute of Technology, NIF Institute of Engineering, Mysore. Dr. Nagaraju holds a PhD in image processing from the University of Mysore and has an impressive academic background. With over 15 years of teaching experience, he has worked in various institutions, including BGS Institute of Technology and Coorg Institute of Technology. As a lifetime member of Institution of Engineers, MIE, Dr. Nagaraju has demonstrated his commitment to the field of engineering. His research contributions are notable with numerous publications in international and national journals, edited books, and conferences. He has also guided research and reviewed articles in various journals. We are honored to have Dr. Nagaraju with us today and look forward his valuable insights and contributions. Please join us in extending a warm welcome to you. Thank you. Session over to you, sir. Nagaraj, sir.
Thank you, sir. Thank you for the introduction. Very good morning to all. So today I have taken a session on the topic called convolutional neural network for medical imaging. This might be a useful talk for the researchers because nowadays the medical image processing area playing a vital role, okay, along with the AI, ML, and the DL concepts. When we are going to club the diagnosis or at the time of detection or the prediction of the diseases, normally the people will go behind the pre-trained the models like AlexNet or VGG16, etc. At the end of the research, what is the major required thing? Any contribution from the researcher as a novelty kind of things has been included in the research is the main key point. So for that one, the one and only solution is build your own model and compare that with the existing models. Okay. In this particular context, I have taken a CNN model, how to develop our own proposed model so that you can have the same type of analysis which normally in the research we are going to perform, okay, at the end or to conclude that one is the key thing that I am going to give it in this particular session. So the complete session is mainly focused on overview of medical imaging, followed by deep learning and machine learning models, which are useful for the medical image analysis. Along with that one, I have taken a case study where I have used the CNN model for the diagnosis of the cancer. And finally, I will conclude that with the results, how normally we are going to get at the time of the prediction of the disease. This is the overview of this particular session. medical imaging. So when the doctors need to reveal the internal structure of the bone which has been got fractured, or if the diagnosis is going to be required in order to treat the patient properly. During that condition, the medical imaging play a vital role in order to diagnose and properly give the prescription accordingly. So that is the one thing where the medical imaging will be very much useful. For example, if you take a cancer and non-cancerous tissue, which is present inside the body, it is highly impossible to notice whether it is a benign or a malignant case condition. During that condition, by looking into that one, we cannot come to, or the doctors cannot come to conclude that it is a normal or going to be a malignant or a benign case condition. So ultimately, so one should go with the medical image. The devices which are being available for this is going to be the one more important thing that we need to know. Earlier days, the people were using, suppose if there is a bone fracture is been happening inside the body, normally they are going with the X-ray kind of things. Nowadays, the advanced versions of medical devices are being available. If the information is not sufficient to the doctor, then ultimately, okay, so the further, in order to analyze that properly, he might suggest for CT, MRI, or in some application, they might even go for an ultrasound. That is depending on the application. And in order to diagnose the patient properly, so these are the advanced machineries or the devices which are available in the field of medical. So making use of these, we can get the medical images also that will be known. So that means if you want to diagnose that one, we need a print of that. So that means those are called to be as image modalities. We can have a X-ray image, we can have MRI, we can have a CT, ultrasound. These are the major important the data which are being required, okay, for the diagnosis purpose. Who is going to get these kind of data for the researchers? Normally, so this will be available in the hospitals before the existence of the data set like the Kaggle resource, where normally the researcher will find the data set. Earlier, everything will be taken care by the hospital management itself. During that condition, even nowadays also, if you want to get the data from the hospitals, it will be available in the DICOM format. That is the major format, which will be taken care by the hospital management system. Or even we can have in the available format like JPEG, TIFF, PNG, etc. These are the different the varieties of the image modalities which can be used for the research depending upon the application and the form which normally will be available. You cannot straight away make use of the DICOM images. That one point should be aware. So if the DICOM images are being there in the hospital, you need to extract that one into the required format of the model which you do choose. Okay, the required format, it can be a JPEG. Most of the time, the particular models will expect in the form of JPEG. So we are supposed to get the conversion of the DICOM images into the JPEG format is very much essential. The next one is need for a medical image. So the one of the major the need for this medical imaging is early disease detection. We can predict the type of the disease well in advance. And also the diagnosis can be accurate. This will be useful for the doctor. And also in some application, you can go for the telemedicine, where the patient will be monitored in the online platform and the diagnosis can be taken in the online mode itself. And this medical image, once again, is very much essential for the researcher and in order to provide the novel kind of things to the society. Now, as I told earlier, so my the main agenda is the medical image and making use of the available tools in order to provide the result which is expected for the research. Now, as I told earlier, the era is automation. Everything need to be automated. That means whatever the things that you are going to specify, the people expecting the automation. So once you do state automation in the field of medical, either I have to go with AI or I will go with a machine learning or we need to go with a deep learning. So there is a slight the difference will be there among the three. The major thing will be AI, that is artificial intelligence. So actually this AI will simulate the human intelligence using the mechanism. That is the key concept of the AI. So this is the major contributor, so for the machine learning and deep learning. With respect to the machine learning has been considered, actually it is a subset of AI. So here, so the plenty of algorithms will be written. So here the system will learn from the data. So what are the data? That data basically depends upon. Sir,
Slides are not changing, sir.
Okay, sir. Check.
Still, it's in first slide, sir.
I'm changing over here, sir. Okay, sir.
No, sir.
In my system, it is getting changed. Teacher. Yes, sir.
No,
It's
sir.
in the first slide only, sir.
Yes, ma'am.
Yes, sir.
Yeah,
Yeah, now it's changed.
now it's changed.
But the zoom
Okay, sir. Okay.
maximize ಮಾಡಿದ್ರೆ ಇನ್ನೊಂದ್ಸಲಿ maximize ಮಾಡ್ತೀನಿ sir. Now
Continue, sir. Continue.
now it is changing.
Yes,
Yeah,
sir.
now it's changing.
Okay, fine. Shall I continue?
Yes,
Yes,
sir. You
sir.
can continue.
Okay, fine. So in machine learning, actually the system will learn from the data. This is what I'm giving that note. Okay, so the data basically depends upon the specific application. So for example, if you are predicting whether the lung cancer is been present or not kind of thing, so then we have to provide the lung cancerous and non-cancerous image to be as a data for the particular system. And using this data, the machine will learn and ultimately it is able to predict whether it is a benign or malignant by making use of the already pre-written algorithms so for that particular system. Coming back to the last one, so that is deep learning. So deep learning is a subset of ML. Basically, it uses the neural network to automatically learn the features from the large data set. So one of the major difference between a machine learning and a deep learning is, okay, so in machine learning, even with a few data set component, that is with the 500 or even 200, 300, you can train the machine learning models. Whereas if you come to the deep learning, suppose if you want to find out the accuracy, okay, so that means if you want to diagnose the particular patient at the higher rate, you need to improve the accuracy of that system. So during that condition, the data which we have used may not be sufficient to get all the features out of that. So then ultimately the solution is I need to increase the large data set. Okay. So during that condition, okay, so machine learning is unable to take up all the data which you are going to. So then the solution for that one is deep learning. So with that one, okay, so one can get the large number of data set. So with that one, so we can or one can easily predict or the diagnose the particular patient with the maximum accuracy. So is the slide changed now? Hello, can anyone?
Sir, it is not changing, sir.
Checked. Shall I escape that one? Will it be okay?
Okay, sir, it moves.
Okay. Fine.
Yes, okay.
Now, what is the major significance of using the machine learning or the deep learning algorithms? So as I told earlier, the one of the major application of the deep learning is to improve the accuracy of the system. And since it is a automation has been applied on that one, so one can even work out on the early disease detection. It can be any of the disease which can be predicted at the early stage, because you will be knowing that the cancer and all are going to be the dangerous the diseases. If we are unable to predict at the early stage, it will leads into the death. So to avoid that one, we are having a well-known algorithms. So we can make use of that algorithms so that these kind of diseases can be predicted well in advance. As I told earlier, telemedicine, when telemedicine kind of things are being included for the deep learning, the personalized treatment can be done. That means one-to-one. A particular doctor will be allocated for a particular patient and he will be under the monitoring the system. Okay. So can be done by making use of our AI. So along with that one, it has got the few additional, okay, so the weightage like the large scale data analysis, continuous learning, and the cost efficiency. If you go to the few algorithms which are been available in ML and DL, so these are the few list of that. Suppose if you go with the research articles, okay, so most of the time the people will go behind the SVM. So because it will provide the better classification, okay, so out of the list which it is been present. So normally the people will go with SVM and they will compare their research work with Navy Bears, KNN, K-means, or to the certain extent the random forest, okay, or decision tree. So these are the list 3 to 8 what have been mentioned. The people will try to make use of these algorithm and try to compare their work mainly with SV. This is the kind of research what the most of the people are doing. So as I told earlier, we cannot restrict only to that one. Apart from that one, we do have
Nagaraj sir? Hello? Nagaraj sir? Nagaraj sir? Hello?
Sorry.
Nagaraj sir?
Is the screen visible, sir?
Yes, sir, it's visible. Continue, sir.
So with respect to the deep learning has been considered, the people are behind the CNN network. You will be knowing that one, the convolution neural networks. Okay, that is the major hot cake nowadays with respect to the medical imaging has been considered. Okay, so few research work are going on generative. Okay, so adversarial networks, that is abbreviated as GAN, and also RNN. If you search for the paper, you can find out a maximum work on CNN. Okay, and few works on RNN and GAN network. Okay, as I told once again with respect to the machine learning and the deep learning. So basically, the type of models what you choose will depends upon what kind of application or the platform that you are using, followed by the type of the data and the case study what you are going to look in for your application. So depending on that one, you choose the particular algorithms which are available in machine learning. If you're willing to work under that, go with deep learning, okay, in order to show the improvement in comparison with that of machine learning. So hope the slide is changing.
Yes, sir, it's changing.
Now, if you go with the CNN model and all, these are the basic pre-trained models. So like AlexNet, ResNet, and VGG16, Inception V2. These kind of the models are there. As I told earlier, depending upon the application. So basically, when you are going with any specific application, mainly we look forward the two major things. The one is object detection, another one is the classification. Okay, the feature extraction will be a common, okay, in most of the models. Feature extraction will be there. Okay, so as a researcher, you find out whether you are going for a object detection or you are going for a classification. Depending upon that, you can choose the pre-trained model for your application. Suppose if you go for your own model, then you need to know what are the layers that I need to build for my application. That is what I have been taken in next and the upcoming slides. Suppose if you go for the object detection, there are few algorithms or models like YOLO, faster RCNN, and SSD kind of models are there as a pre-trained model. Suppose if you go for a classification, you can choose CNN, ResNet, or DenseNet. Okay, these are the few models you can choose for your application. Before you go to the pre-trained model, it will be better if you can look into the complete architecture of that. That is the key thing. Suppose if you go with the AlexNet, that AlexNet is never going to fit for all kind of applications. For all kind of applications, it is not going to be fit. So that means the layers which are being available in that one are going to be the key thing which will decide whether you are going for a object detection or classification. So that is the one thing that should be there in the mind of research. What you are going to come up with at the end of the particular work is the key thing that should be available. Okay, whether you are going for a detection or you are going for a classification. That should be clear in the mind. The next one, the major steps which are being involved. Okay, so if you go for a particular machine learning algorithm or even for a deep learning kind of algorithms, okay, what kind of the things that I need to carry on? As I told, the application will be decided by the particular researcher. So for that particular research, the first major thing is you need to gather the data. Because without data, you cannot come up with automation kind of diagnosis. That is the one thing. So for this kind of automation, we need a data. The data will be available, okay, in the websites, which will be taken care by, okay, so the particular vendor. These are the few, okay, so the data set where you can get for your application has been mentioned over here. You need to collect all this data. That is the one basic thing that you need to know. Gather the data. So you might be getting all kind of data, okay, in any of the site which have been mentioned over here. Okay. Once you collect the data, the next thing is to prepare the data. So we have already collected the data. What do you mean by the prepare the data? Now, in the preparation of the data, as I told, whether you are going for a machine learning or a deep learning, what is the amount of data that you are having? You need to segregate that because you are going for an automation means you have to train the model. Then you have to test the model. These are the two things that you need to know. You need to prepare the data set accordingly. So which particular data you need to have to consider the data to train and for the test. In some application, the people will go for even validation also. Okay, it will be good even if you can include validation data set at the time of preparing the data for that particular application. Now, the first part of the automation is data. Okay, so gather the data, then prepare the data according to your application. This is the first part. The next one is select the model. As I told earlier, basically, there are mainly two kinds. One is object detection. Second one is classification. Okay, so choose the model, okay, according to which application you are willing to move forward. Based on that one, with the available prepared data, train the model. That is the next thing that you need to look in for. Okay, so once you train the model, I need to see whether the particular model is well fit for my application or not. For that one, I need to evaluate that model. there are various, okay, so the performance parameters are there. Use them, okay, in order to evaluate that model. So once everything finds to be okay, so the final stage is the prediction. That's it. So you take any of the work for the medical image analysis using AI, ML, or DL. This will be a common step which needs to be involved by the research. Data collection, selection of a specific model, train that model, evaluate the model, the prediction. This is the first part. The same procedure need to carry out to validate that model also. Okay, so that is one is train phase, another one is test or validate phase need to be carried. This is the important the steps that will be carried out. So few website the address I have been mentioned it. Okay, so for the researcher, you can visit the specific website. The Kaggle is going to be a generalized, okay, the website address which have been given. Okay, you need to dig in detail in order to get the required data out of that. Because in Kaggle, it is just like another Google. Okay, so that means where you can get n number of the contents over there. So you need to get the required the data for your application. So from that set. So because the previous researcher who are made it use the data for their application, those data you can reuse for your application. Okay, so whereas if you go for the repository, in that, okay, you are able to get the data. Okay, so a genuine data, I can say a genuine data either directly from the patient or from that particular vendor itself. Okay, so for these kind of repository,
Slides as not visible, sir.
Sariga?
Yes, sir. It's visible right now.
Okay, fine.
Once again, it's not visible.
Yes, sir.
Yes, it's visible.
1 second, sir. ಮತ್ತೆ ಪುನಃ ಹೋಗಿ ಬರ್ತೀನಿ.
Continue, sir. Continue.
1 second. ಸರಿಗ
Yes, sir. It's visible.
ಸ್ಲೈಡ್ ಚೇಂಜ್ ಆಗಿದೆ ಅಲ್ಲ ಸರ್?
Change ಮಾಡಿ, sir.
ಚೇಂಜ್ ಮಾಡಿದ್ದೀನಿ. ಅಲ್ಲ, ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? ಈಗ ನೆಕ್ಸ್ಟ್ ಫಿಗರ್ 6 ಅಲ್ಲಿ ಇದ್ದೀನಿ.
10 is showing 10, sir.
ಫಿಗರ್
10th slide. 10th slide.
ಹಾ, ಇಲ್ಲ, ಚೇಂಜ್ ಆಗ್ತಿಲ್ಲ. ಈಗ ಸರ್ 11th ಬಂತ?
Yes, sir. Yes, sir.
ಫೈನ್. ಓಕೆ. So the next part is the machine learning or a deep learning. Okay, so as I told earlier, so here we are having the data set, that is prepared data after segregating the data into the required one. We are going to divide that data into the train and the test. Okay, so the ratio for this one, so it will vary from researcher to researcher. But what I do suggest for you people is try to go with the validation set also. In some application, the people will go with train and set. Okay, so by referring the so many paper, okay, so how they are provide the data segregation will be in the form of 90-10, 80-20, 70-30. This is the least the kind of things that you can provide, okay, as a segregation for training and to test the data. Suppose if you go for the validation also into the consideration, the people will go with 70-30 ratio, 70 for the training, 20 for the validation, and 10 for the test. That is 10% of the original data, 20% of your original data, 70% of the original data need to be taken for test validation and test respectively. That is the key thing. Before you do train, you segregate and prepare the data accordingly. But nowadays, few advanced algorithms are there. Okay, you need not to have this kind of the segregation for training and test. Prepare one data set, automate the system. In the program, you mention how much of data that machine has to look in for training and test. That kind of things are also been there in the model itself. But you need to look for the specific the coding lines which are been required for that. That's it. That is, as I told earlier, everything is algorithm based. In that algorithm, you need to look in for the specific command which will be fit this. Okay, if you are not been able to find the specific coding for that one, ultimately the solution is separate the data and read all the data and send the data to the machine for the training purpose. That's it. So this is the things which you need to include for your application. And the second important thing is at the time of training the data, okay, so in few algorithms, like in deep learning algorithms, the features will be extracted straight away from the medical images itself. We can write the coding in that fashion also. Suppose if you want to go for some specific features need to be taken out of the medical images, then that facility is also there in machine learning algorithms. The feature is extraction. Okay, so that features can be an input to the model. Okay, so if you get back to the previous, that means here, the figure, here you can see the image is the input to the machine learning model. Okay, whereas over here, features which you are been getting out of the images are acting as an input to the models. Okay, so these are the key difference that you need to aware for your applications. So that means from this, what one can conclude is I can provide image directly to the machine learning or deep learning models, or I can provide the features as an input to the models also. If you are going with the features, then it will be available in the CSV format. So as I told earlier, you're training the model. So once the model is trained, we are supposed to evaluate that. So for that one, these are the few metrics which are there in order to judge whether the model, what you are training for the specific application is well fit or not. Suppose if it is not going to fit, on which it will depend. Basically, it will be dependent on the input what you are providing to that model. That's it. Suppose if you change the model, or suppose if you change the feature, which is the input for the model, then you need to retrain the model and test the same case condition until you reach with the maximum accuracy. Okay, you cannot have that model can be used for the application or you cannot come to conclusion to that one. Okay. So ultimately the solution is I need to look in for the images or I need to look in for the features. That's it. These are the key things. If you are fail to get the expected accuracy of that one, ultimately you can state that that model is never going to fit for your application. You need to change the model. That's it. That is the one and only option. Okay. So till to this, okay, so I have taken the basic, the introductory, the part, okay, and overview, not in detail, and overview of the medical imaging and concept of machine learning and deep learning, which is going to be included for the specific application. Now I have been taken, as I told earlier, so machine learning, deep learning, and finally I've been going with a case study followed by results and discussions, which we will out of the and the case study, what have been taken over here is the lung cancer detection using CNN model. Now I'll go in detailed with the CNN model, what actually the CNN model, what are the things which is available in the CNN model, and for the lung cancer, how that model is able to predict the particular the cell is going to be a benign one or a malignant case condition. Now this will be in line with the previous the slide, a generalized one which have been shown earlier will be hold stood. That is the data collection. Okay. The next one is image pre-processing, followed by feature extraction, model training and optimization, image classification, then performance analysis of the model. This is the major, okay, so the things which will be involved in most of the machine learning or deep learning based analysis. Okay, so probably you may not have this feature extraction block. Straight away, you can have this block to the model train. That's it. This is the change in block, what you can notice in that. The data collection, since the data collection here, it works on the lung images need to be taken care. Okay, so I have been taken the data from lung image database consortium and image database resource initiative, abbreviated as LIDC and IRDE. These two are the repository where we can get a pure lung diseased and the normal images, which are very much essential for the research application to predict whether it is a benign or malignant. Even I have provided the link where we have been got that the data content for that.
Nagaraj sir,
Hello, Sarili sir.
once again slides have not visible, sir.
Sariga?
Yes, sir, it's visible.
ಅದೇ ಎಸ್ಕೇಪ್ ಆಗಿ ಬರ್ತಾ ಇದ್ದೀನಿ ಬಟ್ ಆದ್ರೂ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ ಯಾಕಾಗ್ತಿದೆ ಅಂತ ಸಾರಿ.
Continues.
Now this is the data set. Okay, so from where, okay, so we have got the data for our application. Okay, now as I told earlier, once you are collected the data, the next the major thing is, okay, so whether any pre-processing is required for that images. or need to be taken care by the researcher. Suppose if the data are limited to train the machine learning model or a deep learning model, then we have to go with a data augmentation. Suppose if the data size is very much large, then I need to go for the image resizing. That image resizing not only depends upon huge data size, it also depends upon the model what you are using. When you are going for an AlexNet, it will require 227 by 227 format. When you go for VGG16, it will ask for 224 by 224 image format. If you won't provide the data set to the requirement of that model, it won't receive that input at all. That's it. So for that purpose, image resizing is required depending upon the model. So at the time of collecting the data or at the time of performing the data augmentation to improve the size of the data, there might be a chance of the noise. That means at the data augmentation, you are going to rotate, you are going to blur, or you are going to do certain operations on the original image data. During that condition, so if that particular the data is mixed with this kind of the noise, then there might be a chance of providing a false data to the model. Thereby, before you do send the data, okay, so for the training, so remove all those kind of the noise using the available filters. So these are the major the pre-processing the kind of work needed for medical image application. If the data set is limited, I need to increase the data set. For that one, go for data augmentation. Depending upon the model, go with the resize. When you go with the data augmentation and resize, there might be a chance of having the corrupted image also in the form of noise. Use the appropriate filters so that you can have a clean data set for the application. This is the one of the important the things which you need to carry out. So once you are going to do the pre-processing and all, now this is the image data set what you people are having. Okay, if you have a few data, you can see the same data it's been so augmented in this fashion. A clip of that one have been taken. Okay, so how the augmented data will comes out of the image. Suppose if the noisy image is there, you cleaned that noise and have that one. So this is with respect to the pre-processing and its result. Now feature extraction. As I told earlier, the models what we do use, they themselves have an option to get the features out of the medical images. But if you are not satisfied with that features out of that one, okay, if you want to provide some predefined the feature extraction algorithms which are available, then you can make use of these feature extraction algorithms before you are providing the data to the model. Sir, hope this slide is visible now. LBP.
Yes, sir, it's visible.
It is visible. Fine. Okay. So the local binary pattern is the one feature extraction method. Okay. So which has been highlighted over here. So here, the raw image we have taken. Out of that one, So we have taken only a 3x3 information. So with this 3x3 information, so how the LBP value will be taken. Okay. Now here the threshold, the center pixel, what we are going to use is act as a threshold value for each and every value. Suppose if you go with the image size by 128 by 128, in that one, this will be the first 3x3 information. So like that, from first row till you reach the last, that is 128, this process will continuous and the LBP feature will be extracted and it will be stored in another form. That means CSV form. The image will become, okay, so the numbers. That's it. Once again, if you construct the particular CSV, once again, it will be image only, but the format will be different. That's it. So now how this particular LBP will do, let me explain that one. This is the threshold value. So anything, okay, so the pixel value which out of that threshold are normally the threshold value will be compared with the surrounded pixel values for that. If the surrounded pixel is greater than the threshold, it will be treated as 1. If the surrounding pixel is lesser to that, it will be treated as 0. Like that, you can see the another matrix has been generated in this fashion. Finally, that will be multiplied with 2 to the power of n minus 1. It is a 3x3. Okay. And here we are making use of the value of n to be as 8. So that is 2 to the power of the 7, it will become 2 power 0, 1, 2, 3, 4, 5, 6, 7, the last value. So this matrix, how we have been generated, it need not to be a constant one. That means few researcher will go with in this fashion. 1, 2, 4, 8, 16, 32, 64, 128. During that, feature will be a different. Now here in this context, how it has been, we have included is 2 power 0, 1, 2, 3, 4, 5, 6, 7, like this. Okay. So right now, this will be getting multiplied with the previous one. 1 into 1, 1, 0, 0, 1 into 4. And finally, the summation of all the pixels will be added, surrounding pixels will be added in order to get the final LBP feature corresponding to this whole 3x3 matrix. So that means this 3x3 will be replaced with this new feature, 53. So this is how the feature extraction will be carried out. One example I have shown over here. Okay, so apart from that one, even we have the few other feature extraction like GLCM, and you can have a DFT, you can have a DWT, the kind of the features also can be extracted out of the medical image. The next block which has been there is model. As I told earlier, depending upon the application, you can choose your own model to train the data set. Now here I have taken how one can make use of his or her own model to train the data. There is convolutional neural network, which is expected in the research. Most of the research paper, if you have been seen, they will mention that with the name called proposed work. Okay, so this is the proposed the convolutional neural network. Okay, what are the basic building blocks which are being available in that one need to be known. Here it has got 5 different layers. Okay, one will be input and another one will be the output layer. Intermediately, we have the hidden layers. And these hidden layers are known to be clubbed with the convolutional layer, a pooling layer, and a fully connected layers in that fashion. This is with respect to the
ಮತ್ತೆ ಕೇಳ್ತಾ ಇಲ್ಲ
CNN has been considered.
ಅದನ್ನೇ ಇನ್ನೊಂದ್ಸಲಿ ಕಳಿಸ್ತಾ ಇದ್ದೀನಿ.
Now, as I told earlier, a module with respect to the CNN, here we have taken this model to classify the data set what we are using to be in the form of benign, malignant. Or even in some application, the people will go for benign, malignant, and a normal case condition also. Okay, so that means if the cancerous cell is there, okay, sometimes even that can be a normal one, that is benign. Okay, so during that condition, the normal without any tissue, benign, the tissue without any cancerous, malignant, it is a cancerous. Like that, the people will classify. So this is the final, the CNN model, which is required for my application. Okay, so like that, you need to decide. Okay, now this is the complete architecture of that one. Okay, so input, okay, classifier, that is going to be the output model, followed by the feature extraction. This is what I told earlier. The CNN model, whatever the models that we do have, they are able to get the features out of the image itself. But right now, what you are providing the features as input. Out of that feature, again, it will dig the required feature to the classification of the data into the benign and malignant. That's it. Okay, so this is the key thing that you need to know. What are the inbuilt layers are there in the feature, the learning? We have convolution, ReLU, and pooling. Okay, at the time of classification, we have flattening, we have fully connected, and we have a softmax. Now let us move on to the significance of each and every layers which are available. Okay, so in this. Okay. Sir, is the screen visible now? Input image I am showing.
Yes, sir. It's visible.
Input image, fine. So whenever the slide is not moving, please do inform, sir. Thank you. So this is the input image. As I told earlier, this input image, it can be in the color format or it can be in a grayscale. Both the version have been shown over here. So, and these images, okay, are going to be the input for our application. Sometimes we go with okay, so the color, but in most of the application, we do prefer to go with the grayscale images to be as an input for the CNN models. Suppose if you go with a color image, okay, so you will find the one more additional part that is called as depth, that is dimension. Okay, so the height, width, depth, or dimension. Okay, so these are the three informations that you are going to get. But most of the time, if you go with the grayscale, you will find the row and column in the form of height and width. Okay, so this is the one thing that need to be known, the type of input what you have been considered. Okay, with respect to the model has been considered input. The next is, sir, hope the convolution layer is visible. Hello.
Yes, sir.
Convolution layer, I'm showing,
Yes.
sir.
Yes, sir. It's visible.
Okay, fine. Now the convolution layer I have taken how the convolution layer is able to get the feature out of that one. So that is, if you go with the architecture of that one, the convolution, ReLU, and pooling are the major important the blocks in order to getting the required feature out of the input information. Now here I have taken the input 101011, that is in the form of the binary. That need not to be a binary always. That is the one thing that you need to know. Suppose if you go with the grayscale, it will be available from 0 to 255. You can have any number over here. Just in order to analyze that convolution layer, I have taken this simple example. That's it. So now 101. Okay, so this is the particular the input the image data. That data's capacity can be 128 by 120, 227 by 227, or 224 by 224, depending upon the type of model which you have taken for your application. The second thing is the kernel. Okay, so what do you mean by kernel? So actually, the kernel is nothing but a filter. Okay, we can have the different the number of kernel. That means over here, you do find the different the convolutional layers, if you observe that one. How many number of kernels that you are using? Suppose if you are making use of only one convolution layer, it is able to predict the edges of the images. Suppose if you go with one more layer of convolution, that is second layer, it is able to get the shape of that particular image. Okay. Then if you go with the third layer, then it will give the high level feature. Basically, it will be decided by, once again, the type of application what you are choosing. That's it. You can have a one convolution layer or a two convolution layer or a three convolution layer for your application. Okay. Now, how this convolution layer will extract the feature out of that? Okay, if you are come under ECE, you might have been knowing the equation for the convolution. Okay, so y of n is equal to, I have not been shown that one in the PPT. Just I will go with that. Y of n equal to x of n convolved with h of n. And that will be taken from summation minus infinity to plus infinity, x of k into h of n minus k. Okay, that h of n minus k thing, okay, so will slide, okay, so the whole signal from starting point 1 till to the last, the element in that particular matrix or in that image. Okay, this is how the particular, okay, so the sliding will be done in this particular convolution layer. Now the filter. Now here also I have taken the generalized number 1, 2, 3, 4, 5, 6, 7, 8, 9. It won't be like this. Okay. Suppose if you go for the Sobel filter, that is, these are the edge filter, then this value will be -101, -202, -101. Or suppose if you want to sharpen that one, 0, -1, 0, -1, 5, -1, 0, -1, 5, like this. Okay, so this filter value, what you will choose. Right now I chosen randomly or simply as 1, 2, 3, 4, 5, 6, which has not been the case. That is what I'm telling. It will be depending upon the type of filter and in which layer you are using that convolution layer will be taken care by that particular algorithm. Okay. Now, how it will perform that convolution operation, as I told earlier, each and every pixel value will be multiplied with the corresponding kernel value of that filter. Finally, since it is a summation, Okay, and it will proceed for all the elements available in the kernel with the input image package. Same thing as I explained in LBP. 1 into 1, 1 plus 0 into 2 plus 3. Wherever 1 is there, you can notice 1 plus 3, 4, 4 plus 5, 9, 9 plus 6, 15, 15 plus 7, 22, and the last 22 plus 9, 31. This is going to be the feature out of the first, okay? So the convolution operation. Will it stop? No. It will move further. Then what will be the next, the pixel it will take up? It will take up 0, 1, 0. Because 3 cross 3, okay, kernel size you have chosen. 1, 1, 0, 0, 1, 0. This will be the case. And if you multiply that with the kernel filter value, okay, if you cross verify that one, I have calculated over here, and it will comes with 22. Okay. This is what happens with respect to the movement of that. Sir, suppose if I take this slide to the last value, what happens? There is no element over here, right? Okay, so to avoid that one, okay, 0 padding will be included at the time of doing the convolution operation, which is a prerequisite thing for this one. Okay, so right now we are not manually doing that, but since the algorithm will taken care that operation, but as a designer, you should aware of that, the 0 padding. So that means so here, if you go to the last 0, 0 will be included so that it will reach again in the row last. If this particular sliding will comes to this part, so what happens? Again, 2 zeros need to be included at the last. When I do need to stop, once I reach the 2 zeros consecutively, okay, so the summation will be taken care. That means summation from k equal to minus infinity to plus infinity have been shown. Okay, so based on that, the sliding will be taken care till to what value I need to proceed. And till to what value it will take up have been mentioned over here. You can see the last value of output volume will be this one, H. That is nothing but the convolution minus FH, that is nothing but the filter size, that multiplied by the width minus FW, that is the width because it is 3 by 3 plus 1, where H and W are going to be the size of the original image which you do consider for that. Okay, so this is how the complete convolution will happens with respect to the image has been considered. So is it is fixed to 3 by 3? No. You are having an option even to change that kernel size by 5 by 5 also. So normally we do go with the odd number. Okay. So for the selection of any kernel, we cannot choose 1 by 1 because it is a tedious process. Okay. We are going to get the same value. Okay. Then 2, you cannot. Then option is 3 by 3, 4, no. Then 5 by 5, like that. Okay. So this is the required thing with respect to the convolution layer and how the feature will be extracted by making use of the convolution layer, which is the first, the part of extracting the required feature out of the image. The next information we need to know is pooling layer. Okay. So in pooling, we have 2 kinds of the pooling out of that one. So assume that the matrix which have been shown over here, it is come out of the convolution. Okay. This is the input for the pooling layer. Now here we are been with 2 different the pooling. Okay. So the one is going to be the maximum pooling and another one is going to be the average pooling. What the pooling will do, basically the pooling is mainly used to the spatial dimensionality reduction. That means earlier the huge feature sets are there, that will be reduced to the certain extent if you go with the pooling. That's it. And thereby it will take off the unwanted features out of the image. That's it. By doing the max or an average pooling. Okay. So the important features will be retained, which are very much essential for the prediction purpose. So the same thing holds good for this one. So here the pooling stride, okay, so needs to be a 2x2 matrix only. So like that it will stroke. Okay, so one after the other. 8. Next thing is 7, 5, 9, 5 will be the taken care. Okay, so followed by it will move on in order to get the respective the pixel value for that one. Okay, so this is how the pooling the value, okay, so will be stored. Okay, so with respect to the matrix which I have been shown over here. The next, the one more, the important block for the extraction of the feature is ReLU. Actually, it is a activation function, and it is basically used to allow the model to some complex pattern. This is the one of the major application of the ReLU. So in the graph itself, we have been shown that there is no negative values will comes to that. Okay, so that means out of the, okay, so the max pooling what we are having, if there is a negative values are there, it will make that one to be as 0. Okay, so that it is able to get the, once again, the required features out of that. These are the major 3 important the blocks, okay, so which are used, okay, so in order to extract the features out of the image. Sir, slide move agidella sir, flattening alli idini. Hello.
Yes, sir. Audible, sir.
Flattening screen alli idinalla sir. Screen.
Sir, ಬರ್ತಾ ಇದೆ.
ಬರ್ತಾ ಇದಲ್ಲ. Okay. So the next and the one more the important the network layer is flattening. Once again, the flattening, what it will do is the particular pooled feature what we are having. Okay, so that will be completely it will comes to the column matrix. That is the one thing what I can state. So here I have been shown okay, a 3x3 square, 3x3 square matrix, and the role of the flattening, okay, so to be as the column. This is the one thing, okay, so what we need to know with respect to the flattening. That's it. Okay, so that means the complete matrix will become a column one, which will be required to extract the extracted feature need to be there in the form of column. That's it. So before we go to the prediction, the fully connected layer where it will take the flattened the data to be as an input part. Okay, so we can have a fully connected layer for our application. Here also in fully connected layer, you can have n number of the layers for that one. In each and every layer, okay, one can make use of the ReLU to be as an activation function. Okay, before okay, so it will reach to the output one. So at the output one, once again you can make use of the activation functions. Okay, you cannot use an activation function over here to be as a ReLU. The prediction ReLU function, the particular ReLU function cannot be used over here. So here, normally we will go with the either softmax or one can go with a sigmoid for the application. So depending upon the application, okay, so either you can go with a sigmoid or one can go with a softmax for the application. If you go with the sigmoid, then you can go with a classification like a binary, yes or no case condition. If you're willing to work for a multi-class, that means where the category, okay, or the classification need to be carried out more than 2, then one can choose for the softmax for their application. Okay. Now this is with respect to the few layers which are been there. So finally, okay, so if you can observe the number, so before the prediction, everything will be in the numbers because the machine will understand only the numbers. Okay, we have represented that to be in the form of data over here, 0.95 and 0.05. Okay, so here the 0.95, the weightage for the benign will be more in comparison with that of malignant. So therefore, okay, so the particular system will predict the input to be as a benign. Like that, the prediction will be done depending upon the weight value, what we are going to get out of the model. Okay. Now the development of the model. Now here I have shown okay, so the development of a CNN model using a MATLAB for my application. Now you can see here, I have used 8 3x3 convolution layers. It depends upon the application. We cannot fix 8 or 10 or 3, something like that. Okay. So the next is I have used ReLU for my application. I have used MaxPool for my application. Okay. Similarly, this is the one set, as I told earlier, convolution layer, ReLU, MaxPool. This is the one set for feature extraction. So for my application, it is not sufficient. Again, I'm using the few more convolution layer. You can see 16 3x3, again ReLU, again Max, again 3x3, again ReLU. So till to this, I have used 3 different the convolution set. As I have already noticed to you people, each and every convolution layers has got its own significance. So like edge detection, shape detection, and high level feature extraction. I have implemented this work for high level feature extraction. So thereby I have used all the 3 convolution layers for my application, followed by fully connected layer and a softmax, because it is a multi-class applications which I have been chosen for my case study. Okay, so my case study is to predict whether the tissue is going to be a benign or a malignant or it is a normal case condition. Okay, now the model is ready. Now if the data is ready with you people, okay, so one has to train the data. So once the model has been trained, then this is the results which results out of that one. Okay, that is the model performance analysis. So this curve is known to be as a MAP, that is mean average precision curve. Mean average precision curve. So here we are plotting the curve for training as well as being for the validation. So now if you observe that one, the accuracy stands with a maximum value. which is the expected thing for any machine learning model. Meanwhile, we need to look in for the loss function also. The loss is at the minimum. Okay, so for a good model, the loss must be as much as minimum, and the accuracy needs to be high for the model. The next one is the confusion matrix, where it will take up the true positive, true negative, false positive, false negative values out of the features. Okay, and at the time of the predicting benign, malignant, or normal, this is a simple. Okay, so the confusion matrix, if you can notice that one, so for each and every case condition, okay, so we have reached more than 90% for this one. That suggests that, okay, so the model, okay, so can be used, the model which we have developed can be used, okay, so for the classification of the data into the category, okay, which it has been mentioned. Similarly, the one more, the parameter, okay, so which normally we use is ROC curve, okay. So this ROC curve will state that whether the model is going to well fit for our application or not. Now you can see that a diagonal line we have been plotted for that one. Okay, so basically it will be taken care by the algorithm itself. Okay, if you give to plot that one, it will plot like that only. Okay, so but depending upon the values of false, that is true positive rate, okay, and the false positive rate, okay, so we are going to get a curve like this. Okay, if this particular curve value, okay, it is above the diagonal point, will indicate that it is a good model, and you can use that one to train the data what we are collected. Suppose if any one of the particular case condition falls below that diagonal line, then you need to look care of the data what you have been used for that one into the reconsideration. Okay, so that is the one thing what the ROC curve will state for you people. Along with that one, as I told earlier, those are not the one and only the analysis kind of things. Okay, so that need to be taken care. So there are few other parameters like AUC, accuracy, F1 square, precision, recall. These are the, okay, so the different metrics that will strongly decide, okay, whether the model is good or not. As I told earlier, as a researcher, we cannot rely on the model performance what we have been used. So for the same data set, you need to make use of the pre-trained the model also. And if you are able to compare that with your proposed model, okay, so then you can ensure that, okay, to the certain extent, okay, so the model, okay, so will be good and that can be used for this application. Okay, so with respect to the graph which is mentioned over here, almost it will be nearer to the, okay, so the proposed model. So then we can state that, okay, our model is also good enough towards the prediction of this lung cancer. Can be the conclusion part, what you can do. So with respect to the medical relevant research has been considered, the one suggestion what I do provide to you people is, you are better to get an opinion from the physician, which is very much essential. So once you are able to get the opinion from the physician, okay, fine. Okay, you are going to work for that application. So then ultimately you can 100%, okay, you can ensure that the work what you have been carried out towards research is good enough for your research. Okay, so with this, I will conclude. Okay, so my talk over here. If you have any queries, okay, you can.
Dear participants, if you have any queries, Dr. Nagaraj, sir.
Hello.
Yes, sir. Audible, sir.
Yes,
So
sir.
dear
I'm audible.
participants, you can unmute yourself to ask the questions. Any queries? Hope the session was very informative, and Dr. Nagaraj sir has given the session on a CNN model. It was very informative, and it may be useful for our researchers also. From the Department of Electronics and Communication, SJMIT, I'm very thankful to Dr. Nagaraj sir for giving us a wonderful session. Yeah, if you have any doubts, Dr. Shashidhar PK, sir. Hello.
Hello.
Sir, I think no questions. So we'll wind up. So
Okay, fine, sir.
yeah, any questions? So, okay, the feedback link has been shared in the chat box, and it will be open for 15 minutes. So within that, you may give the feedbacks. And thank you, Nagaraj sir.
Thank you, sir.
Thank you all
Thank
the
you for
participants.
providing an opportunity for me to be part of your 1 week FDP. Thank you, sir.
Yes, sir. Thank you very much, sir. Thank you.
Thank you, sir. Hello. On this.
ಆಗಿದ್ದಾನ ಅವನು. ನಾನು ಹೆಂಗೆ ಬೈ ಜಗಳ ಮಾಡಿದ್ದೀನಿ ಅಂತಂದ್ರೆ ಅವ್ನ ಒಂದ್ಸಲ ಏನಾದ್ರು ಮಾಡಕ್ ಹೋದ್ರೆ ಏನ್ ಮಾಡ್ತಾನ ಗೊತ್ತಾ, ಏನಾದ್ರು ಮಾಡಿ ಹಂಗೆ ಜನಕ್ಕೆ ಗೊತ್ತಲ್ವ ಯಾವ ತರ ಮಾಡ್ತಾರ ಅಂತ. ಸುಮ್ನೆ ಏನಾದ್ರು ಮಾಡಿದ್ರೆ ಏನಮ್ಮ ನೀನು ಇದು ಅಂಬೇಡ್ಕರ್ ಕಾಲೇಜ್ ಕೆಲ್ಸ, ನೀನು ಅಂಬೇಡ್ಕರ್ದು ಕೆಲ್ಸ, ನೀನು ಜಯಂತಿ ದಿನ ಹಿಂಗ್ ಮಾಡ್ಬಿಟ್ಟೆ ಅಲ್ಲ, ನೀನು ನಿಂಗ್ ಒಳ್ಳೇದಾಗತ್ತ ನಿಂಗೆ ಅಂತ ಈ ತರ ಉಲ್ಟಾ ಹೊಡ್ಬಿಡ್ತಾನೆ, ಬ್ಲಾಕ್ ಮೇಲ್ ಮಾಡಿ.
ನನಗೆ ಹೇಳ್ತಾನೆ ಕೆಲಸ ಮಾಡ್ಬೇಕು ನಾವು ತೋರಿಸ್ಕೊಡ್ಬೇಕು ಫಸ್ಟ್ ನೀನು ಅಂತ. ನಾನು ಒಬ್ಬನೇ ಅನ್ಸುತ್ತೆ ಮುಟ್ಟು ಕೊಡ್ದೆ.
ಆಮೇಲೆ
ಮುಂಚೆ
ನಾನ್ ಆಮೇಲೆ ಜಯರಾಮ ಇವರೆಲ್ಲ ಇದ್ದಾಗ ನಾನು ರವೀಶ್ ಅಂತಿದ್ದ, ಅಬ್ಬಾ ಮಾರಾಯ ನಾನು ಯಾರ್ದಾರು ಕೈ ಇದ್ರೆ ಮಾಡ್ತೀನಿ ಕೆಲ್ಸ.
ಫಿಕ್ಸ್ ಮಾಡ್ಬೇಕು ಒಂದ್ ಕೆಲಸ ಮನೆ ಮಟ್ಟ ಗೊತ್ತಾಗಬೇಕು ಒಂದ್ ಕೆಲಸ ಒಬ್ಬರಿಗೆ ಯಾವ ಅಸಿಸ್ಟೆಂಟ್
ಆಮೇಲೆ ನಾನ್ ಮಾಡ್ತೀನಿ ಅಂತಾನೆ ಎಲ್ಲ ಹಂಗೆ ಕೊಡಮ್ಮ ಹಿಂಗ್ ಕೊಡಮ್ಮ ಅಂತ ಏನೋ ಮಾತಾಡೋ ಗೊತ್ತಾನ ಟ್ರಸ್ಟ್ ಅಲ್ಲಿ. ಅಯ್ಯೋ
ಕೆಲಸ ಎಲ್ಲ ಮಾಡಿಸ್ಕೊಂಡ ಬಿಲ್ ಕೊಡುವಾಗ ದುಡ್ಡು ಕೊಡುವಾಗ
ಏನ್ ಗೊತ್ತಾ, ರೈಟ್ ಆಪರ್ಚುನಿಟಿ ನಮ್ ಕೈಯಲ್ಲಿ ಎಷ್ಟಿರತ್ತೋ ನಮ್ಗೇನ್ ಗೊತ್ತಾ, ನಾನ್ ನಂಬೋದು ಮಹಾಭಾರತ ತರಾನೇ ಕೃಷ್ಣ ಇದಾನೆ. ಎಲ್ಲೆಲ್ಲ ಅನ್ಯಾಯ ಆಗತ್ತೋ ನಾವು ಧರ್ಮ ಉಳಿಸ್ಬೇಕಂದ್ರೆ ಅಧರ್ಮದಿಂದಾನೇ ಉಳಿಬೇಕು ಅವರಿಗೆ. ಅದನ್ನೇ ಮಾಡ್ಬೇಕು. ನಾವೇ ನಂಗ ಟೈಮ್ ನಮ್ ಕೊಟ್ಟಿದೆ, ನಮ್ ಬಂದಿದೆ.
ಎಷ್ಟು ಸುಳ್ಳು ಹೇಳ್ತಾನೆ ಸರ್ ಪ್ರಿನ್ಸಿಪಲ್ ಎದುರುಗಡೆ. ನಾನೊಂದ್ ತಂಟೆಗೆ ಹೋಗಿಲ್ಲ, ಅವ್ರ ತಂದೆ ತೀರ್ಕೊಂಡಿದ್ರಂತ, ಅವ್ರ ಖುಷಿಗೆ ಹೋಗಿಲ್ಲ, ಏನೂ ಹೇಳ್ತಿಲ್ಲ ಹಚ್ಚಿಲ್ಲ. ಬಂದ್ಬಿಟ್ಟು ಸಂಡೆ ಹೇಳ್ತಾರೆ ಸರ್ ನನ್ ತಂದೆ ಸರ್ ಅವಳು ವಾಯ್ಸ್ ಮಾಡ್ಕೊಂಡು ನಮ್ ತಂದೆ ಸತ್ತಿದ್ರು ಸಂಡೆ ನನ್ಗೆ ಫೋನ್ ಮಾಡಿ